Dear students, last class we saw up to ABC, C implies D, up to C implies D. Now we come to D implies E. In D, it is given that for any F belongs to H of G, there exists a sequence of polynomial that converges to this F. Now in E, we need to prove that for any f belongs to h of g and for any closed rectifiable curve gamma in g, then integral over gamma f equal to 0. This is what we need to prove. So let gamma be a closed rectifiable curve in g and let it be analytic function on a g, and given from f from the option d, from the option d, that we assume that sequence of Pn be a sequence of polynomial such that f equals limit Pn in h of g. Now we know that each polynomial is analytic in a C, and since C is a and gamma is a closed rectifiable curve in G. G is a simply connected region, so every closed rectifiable curve in G can be considered as homotopic to 0. From G എന്ന് പറയുന്ന simply connected regionിലുള്ള ഏതൊരു closed rectifiable curve എടുത്താലും അതെന്തായിരിക്കും homotopic to 0 ആയിരിക്കും. So we can say that each polynomial is analytic in C and gamma is homotopic to 0. Then we can say that integral over gamma Pn equals 0 because gamma is a closed rectifiable curve. Pn is an analytic function. Then by Cauchy's theorem, for any analytic function, integral over a closed rectifiable curve is 0. Now we have given in D, what we assume that f equals limit of Pn. Now taking integral over gamma on both sides, we will get integral over gamma f equals integral over gamma limit Pn. Taking limit outside, we will get integral over gamma Pn, and we know that integral over gamma Pn is 0, therefore limit 0, and the answer is 0. Therefore we got that for any f belongs to h of g and in closed rectifiable curve gamma, integral over gamma f is equal to 0. Hence the proof of D implies E. Next, E implies F. Next we have E implies F. In E it is given that for any analytic function f and for any closed rectifiable curve gamma, for any analytic function f and for any closed rectifiable gamma, integral over gamma f equal to 0. Now in F we need to option F, we need to prove that every f belongs to h of g has a primitive. F in h of g has a primitive, that is, we need to write that this f equals some f dash. So this is what we need to prove. Now fix some a belongs to g. Now we can define a curve such that curve f of z that is equal to integral a to z f of z. Okay, now here we are taking gamma as integral over gamma f of z, where gamma is a path from a to z. Okay, so we define capital F of z as integral a to z f of z. Now, since G is simply connected and f from G to C is an analytic function on G, then f has a primitive. This is a theorem. Then G is simply connected and f from G to C is analytic in G, then small f has a primitive in G. And for Z0 belongs to G, we have find what is f of gamma, f of z what is then f of z minus f of z naught divided by z minus z naught. This equals 1 by z minus z naught into f of z can be written as, we define f of z as a to z small f of z. So this is a to z small f of z minus f of z naught means a to z naught f of z. Okay, f of f of z naught. Anyway, this implies 1 by z minus z naught into, we call it as gamma and we call it as gamma 2. So integral over gamma 1 minus gamma 2 of f of z. Okay, into f of z, and gamma 1 minus gamma 2 is a closed rectifiable curve and integral over f is equal to 0, then this will tends to 0. That implies mod f of z minus f of z naught divided by z minus z naught is tending to integral over f, that is integral over z minus integral of f of z naught divided by z minus z naught minus f of z is less than epsilon when z minus z tends to z naught. That implies this can be considered as taking limit. This can be considered as f dash. So we have f dash equal to small f. Therefore, small f has a primitive. Has a primitive. Now comes to the next section, that is f implies g. F implies G. F gives that f means any f has f any f has a primitive, has a primitive. This is f. And g, we need to prove that for any f belongs to h of g, g എന്ന് പറയുന്നത് for any f belongs to h of g such that f never vanish on g, that is f of z is not equal to 0 for every z belongs to g. That means f does not vanish on g. Then there is a function vanish on a g, then there is a function, there exists a function g in h of g. H of g ക്കകത്ത് ഒരു function നമുക്ക് കിട്ടും such that f of z equals exponential of g of z. This is what we need to prove. We have given that f has a primitive, and from this we need to prove that any f belongs to h of g and f does not vanish on g. That means f of z is not equal to 0 for every z belongs to g. Then there exists a function g in h of g such that f of z equals exponential of g of z. Actually, this is a theorem that you studied in your last semester. Okay, now since f of z, here it is given, since f of z is not equal to 0, f of z is not equal to, since f of z is not equal to 0 and f belongs to h of g, f dash divided by f is defined and analytic, because f belongs to h of g means it is analytic function. So f dash exists, f derivative of f exists, so f dash is exists, and f does not equal to 0 for every z implies f dash by f is a well defined function and f dash by f is an analytic function. So by our assumption, by f, this is by f, we have given that for any analytic function in h of g, the primitive is given. So there exists, for this particular function, there exists a primitive f such that f dash equals this point. Here our function itself is f dash by f. So capital some function f such that capital F dash equals small f dash divided by f. That means our function, which implies there exists a function g equals f plus c that satisfies f of z equals. So we can explain it. We have a theorem that if g is simply connected, g is simply connected and f is analytic in g, f is analytic in g, then there exists an analytic function g such that f can be written as e raised to g of z, that is exponential of g of z. This is our result. So now we got that g is simply connected and our function f dash by f is analytic. Then we can find a function such that g such that f equal to e raised to g of z. Okay, so from here it is like that. So here it is given as f dash capital F dash equals small f dash divided by f, and taking log on both, sorry, integrating we will get, now integrating we will get, ഇവിടെ integrate ചെയ്യുമ്പം f dash ഡെറിവേറ്റീവ് പോയി capital F plus some arbitrary constancy equals f dash by f. Integral of f dash by f is log f. Now taking exponential means e raised to f plus c equals f. If we take f plus c as a small g, then we can write f equals e raised to g. Hence our result. Our next explanation is for g equals h. G implies h. In g, it is given that for any f belongs to h of g, and this is a g. In G, it is given that for any f belongs to h of g and f of z is not equal to 0 for every z in G, then there exists a function g such that f can be written as e raised to g of z. F of z equals e raised to g of z, and in h we need to prove that for any f belongs to h of g, there exists and f of z not equal to 0, then there exists a function g such that we need to prove that f of z equals g of z the whole square. Here we need to prove that f of z equals g of z the whole square. So I am giving another proof instead of the proof given in your note. So just from g it is given that from G, it is given that for any f belongs to h of g, we have a function there exists some g of z such that f of z can be written as e raised to g of z. So this can be written as e raised to half into g of z plus half into g of z, and this equals e raised to half into g of z into e raised to half into g of z, and this can be written as e raised to g of z divided by 2 the whole square. Okay, that means e raised to g of z, e raised to half into g of z the whole square, complete the whole square, and e raised to g of z by 2 can be taken as some h of z, so we will get h of z the whole square. So ultimately we will get that f of z equals some analytic function h of z the whole square. Hence the proof of the part G implies h. Now next H implies I. Now next H implies I. In H it is given that for any f of z belongs to H of g, there exists a function g of z such that f of z can be written as some g of z the whole square. Now we need to prove that g is homomorphic to G is homomorphic to the unit disk is homomorphic to the unit disk. Now we need to prove that G is homomorphic. G എന്ന് പറയുന്നത് യൂണിറ്റ് ഡിസ്കിനോട് ഹോമോമോർഫിക് ആണ് എന്ന് പറഞ്ഞാൽ യൂണിറ്റ് ഡിസ്ക് മീൻസ് സെറ്റ് ഓഫ് ഓൾ Z such that mod Z is less than or equal to 1. ഇതാണ് യൂണിറ്റ് ഡിസ്ക്. ഇങ്ങനെ ഒരു G is homomorphic to D implies there exists a homomorphic function AF from G to D such that F is homomorphic. Homomorphic means F should be 1 1 on 2 and F inverse is continuous. Homomorphic no homeomorphic കേട്ടോ. Homomorphic എന്നല്ല homeomorphic എന്നാണ്. 1 1 ആയിരിക്കണം, on 2 ആയിരിക്കണം, F inverse എന്തായിരിക്കണം, continue ആയിരിക്കണം. Now come to the proof of the theorem. So if G equals the complete plane C, then we have a function f of z equals, here it is given, f of z equals f of z equals z divided by 1 plus mod z. Then this is a homeomorphism between G and D. It is a well-defined homeomorphism because this is a Mobius transform. It can be considered as a Mobius transformation. So this is 1 1 on 2 and inverse of this function is also continuous and hence we can say that it is a homeomorphism from G to D. And now consider the second case. If G is not equal to C, then by Riemann mapping theorem we can find such a function f. And the Riemann mapping theorem states like this: if let G be a region, which is not the whole plane, that means G is not equal to C, such that G is not equal to C, then say whole plane, and such that then for every non-vanishing analytic function on G, for every non-vanishing, that means f of z is not equal to 0 for every z, for every non-vanishing analytic function in G has an analytic primitive, has an analytic square root, and if A belongs to G, then there exists an analytic function f from G to C having the properties. First one is f of A equals 0 and f dash of A is greater than 0. Second property is f is 1 1. Third property is f of G equals D. That means the unit disk. So by this theorem we will get an f which is 1 1 on 2 and f of A equal to 0, f dash of A is greater than 0 means inverse is also a continuous function. Therefore this mapping will give an analytic function. So a homeomorphic function. It's a homeomorphism from G to D. So by this theorem we can find a continuous function f. So G and D are homeomorphic. To say that two sets are homeomorphic, we need to show that there exists a function that is homeomorphic. So now we got a homeomorphic function. Now come to I implies A. I implies A means we need to show that G, we have given that G and D are homomorphic. We need to prove that G is simply connected. So since G and D are homomorphic, we can always find a continuous function. So clearly there exists, that is here, there exists a continuous function H from G to D, and gamma is a closed rectifiable curve in G. We need to show that G is simply connected, and from the definition it is clear that G is simply connected if and only if for any closed rectifiable curve gamma that is homotopic to 0. So we are going to prove, we choose an arbitrary curve gamma, closed rectifiable curve in G. We need to show that this gamma is homotopic to 0. Now define another curve or another function sigma of S as a combination of H and gamma. The gamma is a closed curve, H is a continuous function, and continuous image of a closed set is closed. So we can say that this sigma of S is closed. And also this is a closed curve in D. ഇതെന്ന് പറയുന്ന ഗാമ സിഗ്മ ഓഫ് എസ് ഈസ് എ ക്ലോസ്ഡ് കർവ് ഇൻ ഡി ആണ്. ഡി എന്ന് പറയുന്നത് നോട്ട് എ ഹോൾ ആണ്, അതൊരു റിസൾട്ട് ആണ് കേട്ടോ. അതിനകത്തുള്ള ഏതൊരു ക്ലോസ്ഡ് റെക്ടിഫയബിൾ കർവ് എടുത്താലും നമുക്ക് പ്രൂവ് ചെയ്യേണ്ടത് ജി സിമ്പിളി കണക്റ്റഡ് ആണ്. ഇപ്പോൾ പറയുന്നത് സിഗ്മ ഓഫ് എസ് എന്ന് പറയുന്നത് ഡിയിലുള്ള ഒരു ഫംഗ്ഷൻ ആണ്. Sigma of S is a function in a D ആണ്. ഈ D not a whole ആയതുകൊണ്ട് we can say that any closed curve in D is homologous to 0. That means hence sigma of S is closed in D. It is homologous to 0. That means this sigma of S is homologous to 0. Since it is homologous to 0 means it is homologous. Sigma is homologous to some constant curve gamma naught. Okay, some constant function, or it is homologous to 0. So ഇത് homologous ആണെന്ന് കാണിക്കണമെങ്കിൽ എന്താണ് ഡെഫിനിഷൻ അനുസരിച്ച് there exists a continuous function gamma from I square to D such that gamma of S0 എടുക്കുമ്പോൾ നമുക്ക് ആദ്യത്തെ ഫംഗ്ഷൻ കിട്ടണം, that is gamma of S. രണ്ടാമത്തേത് gamma of S1 എടുക്കുമ്പോൾ രണ്ടാമത്തെ ഫംഗ്ഷൻ കിട്ടണം, that is 0. So we get 0, and gamma of 0t equals gamma of 1t. So this kind of a function exists because gamma of is a closed curve in D, and in D for any closed rectifiable curve is homologous to 0. Now define another function gamma equals H inverse composition gamma. This is small letter gamma. So consider now we are proving that this also satisfies the homotopic continuous function. Find gamma of S0. Gamma H inverse composition gamma of S0. Gamma H inverse of gamma of S0. H inverse of gamma of S0 is we got it as sigma of S. That means H inverse of sigma of S is taken as H of gamma of S. H inverse of H of gamma of S. H inverse and H get cancelled, and last finally we got gamma of S. So capital gamma of S0 is gamma of smallest. Now find the gamma of capital gamma of S1, that is H inverse composition gamma of S1. Gamma of S1 is given as 0. So H inverse of 0, this is a constant curve. H inverse of 0 is a constant curve. Also gamma of 0t equals H inverse of gamma of 0t. ഇതിങ്ങനെയാണ് എഴുതിയെങ്കിൽ 0t, gamma of 0t is equal to gamma of 1t. So we can rewrite this as gamma of 1t. That means there exists a function such that satisfies every properties of a homotopic function. That means ഏതിനോടാണ് homotopic ആകുന്നത്? ആദ്യത്തെ curve രണ്ടാം. ഇവിടെ gamma of S is homotopic to H inverse of 0. Where H inverse of 0 is a constant curve, we can say that gamma is homotopic to 0. Since gamma is homotopic to 0, we can write it as gamma is simply connected. Next, if H implies J. In H, it is given that for any analytic function f, there exists a function g such that f equals to some g square. Okay, now we need to prove that if u is a harmonic, if u from G to R is a harmonic function, then there is a harmonic function v from G to R. So if we assume that u is a harmonic function, then we can find a function v from G to R such that f equals u plus iv is analytic on G. Now come to the proof. Here the proof is only one statement. Suppose G is not equal to C. Then by using Riemann mapping theorem, there exists, and the last slide we already given the Riemann mapping theorem. That means for any simply connected region D which is not the whole plane, then there exists an analytic function f having the properties f of a equal to 0, f dash of a greater than 0, f is 1, 1, f of g is d. That means that is a 1, 1 on 2 continuous function. Therefore we can say that implies h is a 1 which now there exists a continuous function like this. So here f h is that continuous function. H is from G to D. D is also part of R. So we can find a function from H from G to D. Now if U from G to R is a harmonic, we can define another function u1 equals d to R from D to R. The function g in the d lekana, we are defining a function u1 from D to R such that u1 equals small u. That small u means define if there exists a harmonic function. So this u composition H inverse. Now this is also a harmonic function because u is a harmonic function, H inverse is continuous, therefore u1 is again a harmonic function on D. Now we have another theorem, and the theorem statement is like this. Let G be either the whole plane C or not. Then there exists a harmonic function v1 from D to R such that f1 equals u1 plus iv1 is analytic in D. Is analytic in D. So let f equal. So this is the statement of the theorem. So let f equals f1 composition H, then f is analytic on G, and U is the real part of f. U is the real part of f. Real part of f, and V equals imaginary part of f. That is V1 composition H is the complex conjugate. This is the theorem. So if either G is the complete plane or some portions of C, then there exists a harmonic function. If there exists a harmonic function V1 from D to R such that V1 F1 equal U1 plus I is analytic in D, and if we define F equals F1 composition H, then F is analytic on G, and U is the real part of F, V is the imaginary part of F, and V is defined as V1 composition V1. ഇവിടെ നമ്മൾ ഡിഫൈൻ ചെയ്ത V1 composition H. ഇതാണ് നമ്മുടെ തിയറം എന്ന് പറയുന്നത്. So by this theorem which follows that H. ഈ തിയറത്തിന്റെ സ്റ്റേറ്റ്മെന്റ് തന്നെയാണ് നമുക്ക് പ്രൂവ് ചെയ്യാനുണ്ടായിരുന്നത്. ഓക്കെ, അപ്പൊ ഈ തിയറം എഴുതുക. തിയറം എഴുതിയിട്ട് ആൻഡ് ഇഫ് ഓൾസോ ഫോർ G ഈക്വൽ ടു C ആണെങ്കിലും ഇത് സാറ്റിസ്ഫൈ ചെയ്യും. കാരണം തിയറത്തിന് സ്റ്റേറ്റ്മെന്റ് തുടങ്ങുന്നത് അങ്ങനെയാണല്ലേ. ഐദർ ഇറ്റ് ഈസ് എ ഹോൾ പ്ലെയിൻ ഓർ നോട്ട്. Then if there is a harmonic function V1 from D to R such that F1 equals U1 plus IV1 is analytic on D. Let F equals F1 composition H, then F is analytic on G and U is the real part of F. Then ഇത് രണ്ടും അനലിറ്റിക് ആണെങ്കിൽ F1 equal to U1 plus IV1 ഒരു അനലിറ്റിക് ഫംഗ്ഷൻ ആണ്. അതിൽ U1 എന്ന് പറയുന്നത് റിയൽ പാർട്ട് ഓഫ് F ആണെങ്കിൽ V1 എന്ന് പറയുന്നത് എന്തായിരിക്കണം? ഇമാജിനറി പാർട്ട് ഓഫ് F ആയിരിക്കണം. So this follows the theorem. Now next we need to prove that J implies G. J implies G. Now suppose F is from G to C is analytic f of z not equal to 0, where F real part of F equals real part of F equals real part of F equals U and imaginary part of F equals V. Now define a function U from G to R. Now we define a function U from G to R such that U of xy equals log of mod f xy. This can be written as log of mod f of xy ഉള്ളതിനെ x plus iy എന്ന് എഴുതാം. ഇനി ഇതൊരു കോംപ്ലക്സ് നമ്പറിന്റെ ഇമേജ് ആണ്. പക്ഷെ അതിന്റെ മോഡുലസ് വാല്യൂ എടുത്തു കഴിയുമ്പോൾ we will always get a real number. So this is always a real number. This is always belongs to this is always a real number and this can be separated as log of mod ഇതിന്റെ റിയൽ പാർട്ടും ഇമാജിനറി u of xy plus I v of xy. x നെ നമ്മൾ u of xy എന്ന് എഴുതി, y നെ v of xy എന്ന് എഴുതി, which implies log of മോഡുലസ് വാല്യൂ എടുക്കാന്ന് പറഞ്ഞാൽ root of x square plus y square. x ന്റെ സ്ഥാനത്ത് u ആണ്. So log of u of xy square plus v of xy square whole raised to 1/2. U and V are harmonic implies the defined capital U is also a harmonic function. The harmonic function ആണെന്ന് പറഞ്ഞാൽ dou square U by dou x square plus dou square U by dou y square is equal to 0 ആയിരിക്കും. Now let V be the harmonic conjugate of U. Then G can be written as ഈ ക്യാപിറ്റൽ യു, ഇത് സ്മോൾ യു ആണ്, ഇത് ക്യാപിറ്റൽ യു ആണ്. ഇവിടെ നമ്മൾ വേറൊരു ക്യാപിറ്റൽ ബി എന്നുള്ള ഫംഗ്ഷൻ ഡിഫൈൻ ചെയ്യുവാണ്. ഏത്? നമ്മുടെ ക്യാപിറ്റൽ യുവിന്റെ ഹാർമോണിക് കോൺജുഗേറ്റ് ആയിട്ട് വരുന്ന ഫംഗ്ഷനെ ക്യാപിറ്റൽ ബി എന്ന് വിളിക്കുകയാണ്. ദെൻ ജി ഈക്വൽസ് യു പ്ലസ് ഐ വി ഈസ് അനലിറ്റിക് ഓൺ ജി. ഇപ്പൊ നമ്മൾ പഠിച്ച തിയറം അനുസരിച്ച് യു ഹാർമോണിക് ആണ്, ബി എന്ന് പറയുന്നത് യുവിന്റെ ഹാർമോണിക് കോൺജുഗേറ്റ് ആണ്. ദെൻ യു പ്ലസ് ഐ വി വിൽ ഗീവ് എ അനലിറ്റിക് ഫംഗ്ഷൻ ഓൺ ജി. Now define h of z equals exponential of g of z. Analytic function alle. So we can write it as h of z equal exponential of g of z. Then h is analytic and h is not equal to 0. h not equal to 0 കാരണം exponential value ഒരിക്കലും 0 ആവില്ല. It's not equal to 0. Therefore, f of z divided by h of z. Since h is not equal to 0, f of z by h of z is well defined and it is analytic. F analytic and h analytic and therefore this is also an analytic function and mod f by h can be written as mod f by e raised to g. h can be replaced by e exponential of g, e raised to g, and this equals f divided by e raised to g എന്ന് പറയുന്നതിന് നമ്മൾ അങ്ങനെ എഴുതിയിരിക്കുന്ന u plus iv. So this can be written as u plus iv. So f by h can be written as f by e raised to u into e raised to iv. That implies ഒരു കോംപ്ലക്സ് നമ്പറിന്റെ മോഡുലസ് വാല്യൂ എടുത്താൽ e raised to i തീറ്റ എടുത്തു കഴിഞ്ഞാൽ നമുക്ക് എന്താ e raised to x എന്നാണ് കിട്ടുന്നത്. മോഡുലസ് ഓഫ് e raised to i തീറ്റ എന്തെങ്കിലും എടുത്തു കഴിഞ്ഞാൽ നമുക്ക് എന്താ, അല്ലെങ്കിൽ e raised to z എടുത്തു കഴിഞ്ഞാൽ നമുക്ക് എന്താ കിട്ടുന്നത്, e raised to x ആണ് കിട്ടുക, റിയൽ പാർട്ടാണ് കിട്ടുക. സോ വി വിൽ ഗെറ്റ് e raised to u. u is the real part. So e raised to u ആയിരിക്കും e raised to u. And this equals e raised to f എന്ന് പറയുന്നത് u എന്ന് പറയുന്ന ഹാർമോണിക് ഫംഗ്ഷൻ ആണല്ലോ, അനലിറ്റിക് ഫംഗ്ഷൻ ആണ്. ഇതിനെ നമുക്ക് എങ്ങനെ എഴുതാം, f എന്ന് എഴുതാം. കാരണം നമ്മൾ അസ്യൂം ചെയ്യുന്ന എന്താ, f ഒരു അനലിറ്റിക് ഫംഗ്ഷൻ ആണെങ്കിൽ it can be written as the exponential of the another. So we can say e raised to u can be written as f can be written as e raised to u. So this we will get f by f equals 1. So for the function f by g, the range is not open. കാരണം എന്താ, f by g എന്ന് പറയുന്ന ഫംഗ്ഷന്റെ മോഡുലസ് വാല്യൂ എടുത്തപ്പോൾ നമ്മൾ സാധാരണ മോഡ് z ഈക്വൽസ് 1 എന്ന് പറഞ്ഞാൽ എന്താ, യൂണിറ്റ് സർക്കിളിന്റെ ബൗണ്ടറിയിലുള്ള പോയിന്റ്സ്. അതായത് എഫ് ബൈ ജി എന്നുള്ള ഫംഗ്ഷൻ എങ്ങോട്ട് മാത്രമേ മാപ്പ് ചെയ്യുന്നുള്ളൂ, 1 എന്നുള്ള ഒരു പോയിന്റിലേക്ക് മാത്രമേ ബൗണ്ടറി പോയിന്റിലേക്ക് മാത്രമേ മാപ്പ് ചെയ്യുന്നുള്ളൂ. അപ്പൊ അതുകൊണ്ട് അതൊരു ഓപ്പൺ സെറ്റ് അല്ല, ബിക്കോസ് ഇറ്റ് ഈസ് ഓൺ ദി യൂണിറ്റ് സർക്കിൾ. സർക്കിളിന്റെ ആ കേർവിൽ മാത്രമാണ് ഇത് വരുന്നത്. സോ ദിസ് ഈസ് നോട്ട് എ ഓപ്പൺ സെറ്റ്. ഇതൊരു ഓപ്പൺ സെറ്റ് അല്ല എങ്കിൽ നമുക്ക് ഷോർട്ട്സ് ലെമ്മ അനുസരിച്ച് നമുക്ക് എന്ത് പറയാം, യൂണിറ്റ് സർക്കിളിലേക്ക് മാപ്പ് ചെയ്യുന്ന ഏതൊരു ഫംഗ്ഷനെ ഷോർട്ട്സ് ലെമ്മ അനുസരിച്ച് നമുക്ക് എന്ത് പറയാം, there exists a constant c such that f of z equals c into നമുക്ക് f by g എന്നല്ലേ, f by h എന്നല്ലേ, ഈക്വൽസ് ആണ് നമുക്ക് 1 കിട്ടിയത്. നമുക്ക് ഷോർട്ട്സ് ലെമ്മ അനുസരിച്ച് നമുക്ക് എന്താ പറയാ, എഫ് ബൈ എച്ച്, എഫ് ഈക്വൽ ടു എച്ച് എന്നാണ് പറയുന്നത്. സോ ഷോർട്ട്സ് ലെമ്മ അപ്ലൈ ചെയ്യുമ്പം നമുക്ക് എന്തെന്ന് പറയാം, എഫ് ഈക്വൽ ടു c into h of z, which implies c into h of z is e raised to g of z, c into e raised to g of z, which implies e raised to some c എന്നുള്ളതിനെ നമുക്കൊന്ന് മാറ്റി എഴുതാം. രണ്ടിടത്തും ഇതൊരു കോൺസ്റ്റന്റ് അല്ലേ, സി എന്ന് പറഞ്ഞാൽ ആർബിട്രറി കോൺസ്റ്റന്റ് ആണ്. സോ റീറൈറ്റ് ദാറ്റ് കോൺസ്റ്റന്റ് ആസ് e raised to c1 into some e raised to gz. So e raised to a into e raised to b, e raised to a plus b, e raised to g of z plus c1. ഓക്കെ, സോ നമുക്ക് എന്തായിരുന്നു പ്രൂവ് ചെയ്യാനുണ്ടായിരുന്നത്, എഫ് ഓഫ് z can be written as exponential of some function. അതാണ് നമുക്ക് പ്രൂവ് ചെയ്യാനുണ്ടായിരുന്നത്. സോ വി ഗോട്ട് എഫ് ഓഫ് z ഈക്വൽസ് e raised to some function. സോ ഹെൻസ് ദി പ്രൂഫ് ഓഫ് ദി തിയറം. അപ്പം നമുക്ക് ഇതിനകത്ത് ഒരു 7, 8, 10 പ്രൂഫ് ഈ ഒരു സ്റ്റേറ്റ്മെന്റിൽ തിയറത്തിൽ തന്നെ പഠിക്കാനുണ്ട്. ജസ്റ്റ് ഗോ ത്രൂ ദി തിയറം. താങ്ക് യു.